There was a time when I used to get very confused with the formula of the total surface area of a cone. I just couldn't remember it. But that was only up to the time till I came across a very good teacher who taught me where the formula came from. And I still remember him to this day because from that point on, I didn't need to remember a formula ever again. And that's what I'm going to teach you here so that you never have to remember a formula again. So come on, let's nail it. So what we have here is a figure which is known as a cone. You surely must have come across various conical shapes in your real life too. Like there's a birthday cap which is conical in shape, and there's an ice cream cone and lots of other conical shapes all around us. And in today's video we are trying to figure out what the volume of a cone is and what is the surface area. Let's first try and figure out what the surface area of a cone is. And you know that the surface area of any object is nothing but the sum of the areas of all its faces. Now let's have a look at the faces that a cone has. Well, obviously it has got a circular face at the bottom, which obviously has a center and it has a radius. Let's say that the radius is r. And then it also has a height, which is nothing but a perpendicular from the pointed shape of the cone to the center of the base. And because it is perpendicular, that is why it is called a right circular cone. And let that height be called h. And then there is a curved face that it has, which is connecting the circumference of the circle to the top. Now this obviously can't be the height, but because it is slanting, we call it the slant height, and let that slant height be called L. Now let's try and figure out what a cone would look like if we cut it up and open its faces. Well, for that I've got a cone, so we are going to look at the net of a cone. So let's consider this cone, which as you see has a circular base and then it has a curved face. And suppose if we cut the cone open from the pointed top to the circumference along this line that you see, if we just cut it open. So we are just trying to cut it open and see where the various faces are going. So when we open it up, look at where the circular base goes and where this curved face goes. So the circular base goes down and this curved face, it opens up like this. Well, it is not a triangle, it is not a circle, but yes, it looks like a part of a circle. So since it has two faces, the total surface area would be nothing but the sum of the areas of these two faces. So if we figure out the area of the circular base and if we figure out the area of this sector of a circle, we'll be able to figure out what the total surface area is. If you are coming to my channel for the first time today, I must tell you that I keep doing all these math related things on my channel. And if you are a student of mathematics, you must subscribe to the channel, and you can do so by clicking the subscribe button below the video. And do not forget to hit on the bell notification also, because that will make sure that any future upload is going to come into your inbox. So if we look at the circular base, what do you think the area of that would be? Well, obviously it will be pi r square since it has a radius of r. And now let's look at the other face that we have, the curved face which we opened up as we saw in the figure what it looked like. So this, as I told you, is a sector of a circle. Now what we are trying to figure out is what is the length of this arc that is there. So let's just close the cone and open it up again and see what the length of the arc is. So as you see, when we close it up, it becomes the circumference of the circle. So the length of the arc would be nothing but the circumference of the circular base. So now this curved face looks like this, and as we saw, the length of the arc would be nothing but the circumference of the circular base, and since the radius of the base is r, therefore the circumference is going to be nothing but 2 pi r. And now let's try and figure out what the radius of the circle would be. Look at the radius of the circular part. Let us close the cone and see what the radius is. Well, the radius, as you see, is the part where we cut open the cone from, which was nothing but the slant height. So that is going to be L. And since I told you this is a part of a circle, so let's make a dotted circle around it, and we see that the radius of this circle is L. Now what is the area of this full circle? Well, obviously since the radius is L, the area is going to be pi L square. But the area of the sector that we want is not a full circle, it's just a fraction of a circle. And what is that fraction? Well, obviously, as you can see that this sector, it has an arc length of 2 pi r, whereas the full circumference is 2 pi l. So obviously, the fraction is going to be nothing but 2 pi r over the circumference of the full circle, which is 2 pi l. And we find out that fraction of the total area of the circle so that we get the area of the sector. Now, as you can see that the 2 pi and 2 pi get cancelled out. Now the L at the bottom cancels the L square at top and we are left with an L there. And when we combine the two, we get pi rl. So let's write it down here that the lateral surface area or the curved surface area of a cone is nothing but pi rl, where r is the radius of the base and l is the slant height. And the total surface area is going to be the lateral surface area, which is pi rl, plus the radius of the base, which is pi r square. And as you can see from these two, we can factor out the pi r and we are left with L here and we are left with R here. So now that we have figured out what the lateral surface area or the curved surface area of a cone is and what the total surface area of a cone is, let's try and figure out what the volume of the cone would be. Well, so to figure out the volume, I'm going to draw something like this so that we don't have a cone, but we have a sort of a prism. So in case of a prism, you know that the volume is nothing but the area of the base, which in this case is going to be pi r square, and we multiply it by the height. And you know that it has the same height, which is h. But we are looking at the volume of the cone. We are not looking at the volume of the cylinder that we have made. And if you are looking for a proof of this, you will learn it in later classes when you start learning about calculus, because that requires calculus. But I must tell you that you can do this in the laboratory also, that if you have a cone and a cylinder with the same radius and with the same height, if you fill up the cone 3 times with water and put the water in the cylinder, in 3 times the cylinder would be full. So we can easily say that the volume is going to be nothing but 1/3 of that, and if we combine the two, we get 1/3 pi r square h, where r is the radius of the base and h is the height of the cone. But I must tell you that this works only for right circular cylinders where the height and the radius of the base, they make a perpendicular. So in this case, if we connect the vertex of this cone to the center of the base, it is not going to be a perpendicular and therefore it cannot be called a right circular cone. So these formulas will not work for such a cone. It works only for a right circular cone. Do remember that. So we've figured out what the surface area and volume of a cube and cuboid is. We have figured out what the volume and surface area of a cylinder is. And if you happen to miss that video, you can have a look by clicking this link on the top right corner of the screen. And now we will try and figure out what the volume and surface area of a sphere is. And to find that, all you can do is just click on the video appearing here and it will take you to the video straight away. And if you don't find it here yet, it is because I haven't made the video as yet. So you must click on my picture here to subscribe to the channel, and meanwhile have a look at these videos recommended by YouTube. And as far as the volume and surface area of a cone is concerned, congratulations, you've nailed it. Take care. God bless.